Oh, really? Yeah. The name was Warren Dulles.
Okay, today we're going to finish up on 4.25, the test review. And then we'll move on to 4.26, which is the new set of test reviews that we picked up. And then whatever we don't finish, we'll finish on Monday and test Tuesday. So page 24. And so I think we got through number 8, right? And we did 1 through 8. Okay, so let's pick up number 9. Page 24. Okay, we'll finish up with 9 and 10. And then to page, the back page. All right, so sine x equals cosine 2x minus 1. What's the first thing that we think we want to do? Yeah, get in terms of sine, right? So let's get that cosine 2x expanded. So look on your formula sheets. You'll choose the one that involves sine. That just makes it quicker and easier if everything is in terms of one trig function. So we can choose the 1 minus 2 sine squared. That's right. Doesn't include the minus 1, right? So we're just making that substitution, and then we can work in that minus 1 once we have the rest of the equation down. Okay, so once we make that substitution, we can put things together, combine like terms. Ones cancel out, which is nice. We can put the signs together on the same side and then look for what? Yeah, z equal to 0, take that GCF out. Okay, GCF is sine of x, factor out that sine of x. So once I factor that sine x, I'm really dividing my original 2 terms by sine x, and whatever left over goes inside my set of parentheses. Okay, so now factor form, we can set both parts equal to 0. Sine x equal to 0, sine x equals to negative 1/2. Right, we're looking for solutions on the in the interval from 0 to 2 pi. So where sine is equal to 0, where is sine equal to 0? 0 and pi. Okay, 0 and pi. What about where is sine equal to negative 1/2? Right, so it's in that pi over 6 family, right? Which quadrants though?
7, 5, or 6.
Yeah, so third and fourth. Yeah, third and fourth. Good. right, number 10, first step. Say it again?
Each side to the other side.
Yeah, side to the other side, and then what would you do? Yeah, let's get that double angle taken care of, right? We can expand that sine 2x, so. Use your formula sheet to find that double angle. And add sine over to the left side. Get both of them together, get that 0 to show up on the other side of the equation. Okay, what's next?
Factor.
Yeah, GCF. Okay, set sine equal to 0, set cosine equal to -1/2. Sine equal to 0, we saw that from above, 0 and pi. Where's cosine equal to -1/2? Yeah, in that pi over 3 family, second and third quadrant. Continue on, number 11, page 25. Okay, sine x plus cosine x equals 0. There's no GCF, there's no expansion. There's a little bit of a trick here. And we start off by setting them equal to each other. What's the trick? We actually want to get this into a different trig function to get another look to this problem. What can we create out of this? Okay, sorry. Yeah, so here, right, normally I say that we don't want to divide a trig function because the reason I say that is because we divide, we lose a solution. But here we're going to divide not because we're losing a solution, but because we want to create a different variation. So the trick here is if I divide both sides by cosine, I'm not losing that cosine, but I'm allowing that sine over cosine to create a different look for our problem. And it makes it where it becomes more apparent what we can do, right? So sine over cosine becomes tangent. And cosine over cosine is, right, there's that negative is going to carry over, but it's just -1. So now, right, we couldn't really see a unit circle value out of the original equation, but once we kind of rearranged it and adjusted into a different trig function, now this becomes more familiar, right? We know what that looks like, where tangent is equal to -1. It's in that pi over 4 family, right? Which quadrants? 2 and 4, so. Oh, no, you're right. 7 pi over 4, what's wrong with this solution?
Restrictions.
Restriction, right? Yeah. So it's outside of my interval here. I'm only looking for what's between 0 and pi. So only 3 pi over 4. Okay, 12 through 15, we're doing all values of x, so this is plus 2 pi n, where n is an element of an integer, we gotta include that. Okay, first thing I see is that cosine 2x. Okay. I'm making my decision based off of what I see around it. Everything looks like it'll just be cleanest if I just get that cosine in terms of sine. Okay, looks like this could be a trinomial factoring problem here. I'm gonna bring everything over to the left side. Okay, multiplies to be -4. That's my a times c. Adds up to be -3. So what two numbers multiplies to be -4, adds up to be -3. Reduce the fraction if possible. 4/2 is 2. 1/2 doesn't reduce. I can pull that 2 out in front. Okay. Now that we've factored an easier problem, let's bring sine back in. Okay, anything here? Sine x equals 2? Undefined. Sine x -1/2, third and fourth quadrant in that pi/6 family. This is for all values here, so we need to include what? Any thoughts? Okay, any thoughts as to how we can start this? Yeah, so we can play with that tangent, right? Try to get everything from a sine and cosine. Let's see what happens there. Okay, what do you see? At least we got it down to be times of sine and cosine. Okay, what's next? What can we do next? Yeah, okay. Yeah, so we have an identity, right? We can't really do anything with the sine, but we can do something with that cosine squared. We have our Pythagorean identity, right? Get that cosine squared in terms of sine, and then everything's sort of sine, and we can think of potential factors, right? So I can replace cosine squared with 1 minus sine squared. All right, so now everything's in terms of one trig function. Bring everything over to one side. Well, I'm going to distribute that -2 first. Like you said, I'll go ahead and move that -1 over to the left side. Eventually, everything has to be on the left side anyways. Hey, combine like terms. I want to get my order in place here. Okay, factoring. Okay, multiplies to be -2. Adds up to be 1. What two numbers? Two -1. Reduce that fraction. Okay, let's bring sine back into our factor form. Okay, where's sine equal to -1? Sine is equal to 1/2, pi/6 family, first and second quadrant. Okay, 14. Okay, go ahead and try 14. I'll follow up with the steps. Okay, questions with 14? Okay, 15? What would you do first? Yeah. Say again? Uh, yeah, no square root, no division. What should we do first? Hmm? Oh. Easier. We want those two terms where same side, right? Let's just get together on the same side. The nice thing is it's already showing tangents. So to get to the same side, GCF, we can just move forward from there, right? Okay, where's tangent equal to 0? Well, let's see. Pi over 2, 3 pi over 2, tangent would be undefined, right? Y over x. So if I can, yes, y over x, right? So it should be 0 and pi, right? Tangent of x equals √3 over 3. What's another way of saying √3 over 3? Yeah, same thing as 1 over √3, right? It makes it easier to find it on the inner circle if it's 1 over √3. We know first and third quadrant for positive, 1 over √3 is y over x. It's in that pi over 6 family, y over x. Okay, so I'm going to include 0 and pi so that I can add the 2 pi.
On the graph part, is okay, just like.
That's good. That's perfect. Thank you. Okay. Any questions with 15? Okay, let's move on to worksheet 2. You guys picked this up the other day. Let's see if we can get through the first 4 problems. Does anybody not have this handout? Okay, try number 1. I see an opportunity for that cosine square to be rewritten, right? Okay, get that cosine square to be rewritten as 1 minus sine squared. That's now everything's in terms of sine. Get all the terms on this left side. You can add that 1 from the right side to the left side. Distribute through, combine like terms. Now, the thing that's a little bit awkward here is that sine squared is negative. So either you change all the signs or you move it to the other side. That's what I did. I moved all the terms to the other side. Is we like factoring with that x squared or that sine squared term being positive. It's just a little strange factoring with that first term being negative. So I always like my first term being positive when I go into my factoring steps. Okay, trinomial factoring. Yep.
Keep the parentheses when you stop it. Or keep this.
Oh, the parentheses means that that means you don't include 2 pi. Yeah, so it's right before 2 pi. But yeah, bracket means if it does hit that point, we keep it. But we go close to 2 pi, but we don't quite reach it. All right, a times c here, so multiplies to be -6, adds it to be -5. Okay. -6 and 1, right?
Six negative.
Because we want a -5. -6 times 1 is -6. -6 plus 1 is -5. Reduce the fraction. -6/2 is -3. 1/2. I can pull that 2 out in front.
-2 sine squared x plus 5 sine x plus 3.
You can. It's just. I mean, if you get the same thing I do, then that's perfect. Yeah, but yeah, typically we like to that first term being positive. It just feels more comfortable that way. That's me. Okay, let's bring sine back into our factored form. Sine x minus 3, 2 sine x plus 1. So sine equals 3, sine equals -1/2. Sine doesn't equal to 3. We know sine is only going to live between -1 and 1. So no undefined there, but -1/2. We know third and fourth quadrant in that pi/6 family.
This one, since it doesn't say all solutions, we don't.
Exactly right. Yeah. Yeah, you're always going to be told what the interval is, whether it's from 0 to 2 pi, from 0 to 360, or for all solutions in terms of. Because for all solutions, I'm going to say it's simply all radians. Okay, number 2. Just get that cosine squared by itself, right? And then take the square root. Square root, we get √3 over √4. That's the same thing as what? Yeah, √3 over 2. How many solutions are we expecting? What happens though when we take the square root? Plus or minus, right? Plus or minus on the other side, which means that all 4 quadrants will be represented. Yeah. So everything in that pi/6 family, right? Okay, let's see if we can get through 2 more, 3 and 4. Are we okay so far? 1 and 2. Okay. What do we have to involve here to start off number 3? Yeah, sum of difference identity. So look on your formula sheet, find that difference identity for cosine. Cosine of a minus b, we got to take that bottom operation here. Cosine of a minus b is cosine a, cosine b plus sine a, sine b. Do some cleanup here. What's cosine of 3 pi over 2? 0, gonna wipe that, all that out. Sine of 3 pi over 2. -1. Okay, so we're just left with negative sine x equals -1/2. The negatives can go away, so really just sine equal to 1/2. Two solutions, first and second quadrant, pi over 6 family. All right, one more, number 4. Okay, cosine and sine. We see sine squared. We know we can play with that. Get use Pythagorean identity to get that rewritten. Place sine squared with 1 minus cosine squared. Distribute the -2. Everything's in terms of cosine, so just work towards getting everything on the same side of the equation. Probably a trinomial factoring problem here. Actually, I'm going to move everything to the right side to maintain that cosine squared being positive.
Just change the.
Yes, yeah, you can just change the sign of every term, the same thing, yeah. Okay, trinomial factoring. Multiplies to be -4, adds up to be -3. Again, -4 and 1. Reduce the -4 and 2 to be 2, 1/2. Pull that denominator out in front. Bring cosine back in. Cosine equals 2, no solution there. Cosine equals -1/2. Pi over 3 family in the second and third quadrants. All right, we'll continue with worksheet 2 on Monday. If we get finished with that, we can do worksheet 3, and any leftovers you guys can use as practice to review for Tuesday's test. All right, go and get your book.
There's another.
Oh.
It's.
Oh.